So hello everyone. In the last class, we have seen the electric field and we have started the electric field and have calculated the electric field due to the different geometries. First, we have seen the uh, finite long wire which has an electric field of E parallel and E perpendicular. Perpendicular is given as A lambda by R into sin theta 1 plus theta 1 and theta 2 are taken in clockwise direction from the perpendicular length of the wire, and the P parallel is defined as a how much K lambda by R into cos of theta 2 minus cos of theta 1. And we have also seen how to apply the formula. Then we went to the ring. On the axis of the ring, we have seen the electric field at a point. The distance x from the center is given upon x square plus r square to the power 3 by 2. And the direction of the electric field is along the axis, and we have also seen that the center the electric field is 0 and it is maximum at x is equal to plus minus r by root 2, and the maximum value I hope you have calculated. Then after that we went for a one numerical. We have solved one example in which there is a ring and there is an infinite semi-infinite long wire is there in, and then we have calculated the force due to the ring on that wire. Clear? So these are the things we have seen in the and also we have seen the one more thing, that is a constant electric field. How we solve the questions related to the constant. Now in today we are going to proceed our discussion on electric field, and we will calculate the electric field to the different types of geometry. So let us discuss. And I have also told you how to calculate the electric field as we are learning. So let us start. Okay, in the last class we have seen the ring. So let's take a general case. We have seen the axis of the ring. So let us consider another case, that is general case of ring. Okay, that is a general case of ring. What is a general case of ring? What do you mean by the general case of ring? General case of ring, I am trying to say, like let us suppose that we have a some sector. Okay, we have a some sector. Okay, we have a some sector like this, and this angle is alpha. Angle is also how much? It is alpha. If alpha is equal to pi, it will behave as a semicircle. If alpha is equal to how much? If alpha is equal to how much? 2 pi, then it is a circle. If alpha is equal to pi by 2, it is a quarter. So this is the things are given. Now what is the question? That the question is that you have to calculate the electric field due to this, and then because we want to get the general formula. Okay, so what you will do, that this is my ring. Okay, this is the ring only. Okay, but this is a ring of making an angle alpha. Okay, because we want to generalize it. Now let me define here the lambda, because it is a length, lambda coulomb per meter. Now we want to calculate. So what is the approach? We have to go from theta at angle, or we can do one more thing. From center, suppose this is my center. From center, we come an angle theta and we take a small element. We take a small element that is called as a d theta. Clear? This is a small element d theta, and suppose this length is dx. And what will be that dx? That is small length, that is arc into radius. Sorry, yeah, arc into radius only. No? Theta is equal to arc length is theta into radius. So theta is d theta, and what is radius? Radius is how much? R, correct? So what is my dq in this small? What is my dq? My dq will be how much? It is lambda r d theta. So what is the value we will get? So I can say that we have a small charge here. Okay, we have a small charge here. Okay, and it is not exactly here, it is somewhere else. Suppose this is my small charge. Okay, this is charge is dq, and this is you can say my point, and there is an electric field will be d. This is my electric field d. So there will be component cos theta, sin theta, correct? So this angle will be theta because this angle is theta. So there will be two component will be there. This component is what? D cos theta, correct? And this component will be how much? D sin theta, correct? So we will have a two component D cos theta and D sin theta. Now by conceptually tell which component will be cancelled out. See, if I take the element here, here again I will get cos theta and sin theta. So sin theta will automatically get cancelled out. If you will calculate also, so by symmetry we can see symmetry. We can see the sin theta is component, or you can say horizontal component. Because in the last class we have seen this concept in the ring also. Component is cancelled out. And if you calculate also, you will get the same thing. You will get 0. Okay, horizontal electric field you will get 0. And you can think logically also, na? See, the charge is in this direction, so they will try to repel in this direction only. Correct? 1 coulomb of charge is there, so they will repel in this direction only. So you will get the net force in downward direction only. That is what it is coming. So my dE will be how much? First, that is K into dq. Dq is what? Lambda dx. What is lambda into dx? Sorry, dq is lambda dx. Yeah, dq is lambda dx. That is lambda into r d theta. Okay. And what is the distance? This is the distance. This distance is r, radius of the ring. That is r square. So what is the value you will get? K lambda d theta by r. Correct. Now my E net, this will be what? This will be E in vertical direction, na? Or you can say E j cap, minus j cap, better to say minus j cap. Okay. Integration K lambda into d theta divided by r. What is the value? The value is how much? It is cos theta. Cos theta, you have to integrate from what is the limit of theta? So this is theta is equal to how much? 0. This is theta is equal to how much? Theta is equal to how much? 0 degree. So this will be theta is equal to plus alpha by 2 and this is minus alpha by 2. So integration limit फिर भी minus alpha by 2 from plus alpha by 2. So integration of cos theta is sin theta, sin alpha by 2 minus of minus sin alpha by 2. So 2 sin alpha by 2. So from here you will get 2k. Sorry. So from here, if you will calculate, you will get how much? If you calculate, you will get 2k lambda by r to sin alpha by here. And the direction will be how much? What is the direction? What is the direction? The direction will be in minus j cap. Here, my. Now you have to remember this formula because it cover all the cases. Cover all the cases. Whatever the cases you know, cover all the cases. That is better if you know this formula. Because if suppose my alpha is equal, if it is a circle, the alpha will be 2 pi. So alpha will be 2 pi. Let us take one example, then you will better understand what I am trying to say. What is the conclusion we have drawn? Conclusion. Let me write the conclusion for you. What is the conclusion? The conclusion for you is, what is the conclusion? Okay. The conclusion is, that is, if we have a, okay, the conclusion is very simple if you try to understand. So suppose this is my, it is not a state. Let me draw it a state. Perfect. So if it is, this angle is alpha, you will get the net field in this direction. This is my E net, and value will be 2k lambda by r to sine alpha by 2. That is the conclusion we have got. Okay, that is the conclusion we have got. Clear? This is our conclusion. Clear? This is our conclusion which we have drawn. So if alpha is equal to, suppose I take alpha is equal to some pi by 2, alpha is equal to pi by 2, that means it will behave as a sector, it will behave as a sector, it will behave as a sector, yes or no? If alpha is pi by 2, then it will behave as a sector only, it will behave as a sector. So for this you will get, what is the net electric field? E net. Remember, it is the E net, it is the net component of electric field, remember this. So what is E net? E net will be how much? You can put alpha is equal to pi by 2, so this will be pi by 4, so 1 by root 2, sine pi by 4 is 1 by root 2, correct? So this value you will get root 2 k lambda by r, correct? Any doubt? Similarly, similarly this is the one example. Similarly, you can take one more example, like if alpha is equal to how much? Suppose pi. If alpha is pi, then what is the case? Alpha is pi means it is a semicircle. If alpha is pi, then it will be a semicircle like this. So here, what is my E net for this? So E net will be 2k lambda by r, because sine pi by 2 is, if you put alpha here, pi sine pi by 2 is 1. So the net electric field will be 2k lambda by r. And what is the direction? The direction will be in this direction, E net. Remember, we are taking it as a positive charge. All are positive charge. Negative charge, the direction will be opposite, but the magnitude will remain same. The direction is only opposite. Clear? That I told earlier also in the property of electric field lines. Okay. Clear? So this is the general formula which you have to remember, and this is the conclusion which you have to understand. Clear? Shall we proceed further? Okay. Okay. So our next case is electric field due to the discs. Our next case is, or if you want, we can take one more example also. Let us first discuss one example so that you will get more confident how to use this formula. Let's take one example. Okay. Sorry. Then you will use to. Yeah, suppose this is my question. Very simple only. What you have to do? Suppose I have a sectors. Okay. Suppose it is positive charge. Okay. Suppose this is negative charge. Suppose this is positive charge. And suppose this is also positive charge. And this is lambda coulomb per meter. Sorry, I have written lambda coulomb. Now you have to find E net. Radius is r. What is E net? Magnitude as well as direction, because it is a vector quantity. Okay, so magnitude as well as direction. Remember, always remember this. Radius is r. Okay, radius is r. How to solve this? It is visible. Sorry, it is not visible. Wait. It is not visible in the camera. Wait. Sorry. But yeah, I hope previous things are visible to you. This is the conclusion, okay, which I have given formula, and this is the things. Okay, I hope it is visible. Yeah. Now you can note down this if you have not down. Yeah. Okay. This is also Clear? Okay, now tell me what is the E net for this? How to solve this? See, I can think like this now. This part this part is going to apply the net field in this direction. This part is also going to apply the net field in this direction, and they both are identical. So this will cancel out this part, correct? This part field was going to be cancel out each other. Now this part, you see, this part will apply the net field in this direction, and this part will also apply the field in this direction. So these two part will be get added up. Clear? So what is the field due to this part? Field due to this part will be how much? What is the value? K lambda into R, sorry 2k lambda by R into sine pi by, correct? And also this is going to be multiplied by 2 because why? Because they are getting added up. So this will become 1 by root 2, so it will become 4, that is 2 root 2 to k lambda by, correct? Simple. What is the direction? It is in this direction. That is that you can calculate what is the value of what will be the direction. Here the direction is this, like this, okay? 45 degree angle from the horizontal, basically. So that is why we are getting root 2 here, okay? So this is my E net. Clear? Okay. So next thing is that electric field on the axis, basically we are going to take a disk now. See, initially we have a ring. Ring means we have only the charge at the on the length. Now we are going to take the basically a disk. Disk means it will be like, suppose this is something you can take like this thing. This thing is a disk. It is like circular in shape. So this is a disk, okay? Like that in 2D there is no thickness will be there, okay? So that is my disk. Now we are going to take a disk and we are going to calculate the electric field on the axis of the disk. For example, what I am trying to say, let's see here. Let's see here. First thing is that electric field on the axis of the disk. That is our next topic, or you can say next geometry. So disk means it is a disk and it will be completely filled by some it will be completely filled by it is a completely filled. What I am trying to say, it will be completely filled. It is a disk, okay? Okay, what I am trying to say, that it will be completely filled like this, okay? This is my disk, like this. I am trying to, okay, I am trying to say that it will be completely filled by some value. Let me draw it properly, okay, for you. Yeah, so it will be, yeah, this is my disk basically. It is a completely fill, like this surface is completely closed surface. Since it is a closed, like there is nothing like you, it is not like that you can put your hand inside it. It is a solid surface. So that is a disk. And suppose this is the center of the disk and the radius is r. That thing is given. Radius is r and the center is c. Now what we have to do, what is the our case which we have to do is that we have to take the disk, okay, you have to take the disk. Okay, that is the first thing. You have to take the disk, and from the center, this is my center. From the center at a distance x, what distance? X distance from the center, we have to calculate the electric field at this point. Okay, this is my center. Now question is that how to solve this, how to give the approach to this thing. Okay, because we cannot directly apply the formula. Okay, so what is the approach, how to do this? First you will try to think how to do this, then I will help you solving this. So what is our approach? Because this is also a standard result, you have to remember the formula. Okay, so what is basically what we have to do? From the center, okay, at distance r, we have to cut one small element. Okay, sorry, let me draw it more properly. From center, what you have to do? You have to cut one small element. Okay, what we have to do? We have to cut a small element. Yeah, this is the way. You have to cut a small element, and suppose this thickness of this element is dr, and the charge inside this element is dq. Correct? Charge is dq, the thickness is dr. So basically, what is the area of this dA? Area will be, what you have to do, just take this element and open it. So length will be 2 pi r. Okay, length will be 2 pi r, and what is the thickness? dr. Length into breadth, that is my area, dA. Okay, so similarly we have to take the element here also. So we have basically, this element is here also. Okay, element is there also, this element is also present here. I draw it by, okay, this element is here also, like this. Like this. Yeah, I hope it is clear now. This is the element. Okay, let me shade it down. Okay, this is my element, and its distance is r. Okay, and this is my distance. Like suppose this is my small thing. It is a very, like I am trying to, what I am trying to do, let me try to explain you in the better way. Okay, what my picture is that I am taking a disc and I am cutting into a small ring. With ring I know the formula of electric field. Okay, so from there we will calculate the electric field for the disc. Okay, because if we join that disc, join that ring, we will get a disc only, na. So that is our approach. Here we have taken a very small disc from a center of radius r, and whose thickness is dr, or you can say whose radius, or whatever thickness, radius is r and the thickness is dr. Okay, so what is my dq? Dq will be how much? That is sigma into area, that is 2 pi r into dr, because sigma is given. Sigma is what? My charge density is sigma coulomb per meter square. Okay, that is my sigma. So what is the electric field? I will write. See, electric field will be like this. Yes or no? Sigma coulomb per meter square. And if I ask you what will be my electric field, so you will say, sir, the electric field will be like this. Let me draw it properly. It is coming properly. So our electric field will be This is my electric field. It will be go like this, correct? Here we have a one component, and here in this direction we have another component. This angle is theta because this angle is theta. So here we will get a small electric field dE. Here we will get a one component dE cos theta, correct? And this will be dE sin theta. Now we know this thing will cancel out, this will become 0. Why? If you integrate this thing, you will get 0. Why? Because similarly, because of what is the reason? Because symmetry, that I explained earlier also, because of symmetry. Okay, so what is my dE? dE, can you write? Yes sir, it is electric field due to the small ring K. Q, that is charge on the ring. What is the charge? This is the charge, K Q into X. What is the X? That is the distance of the ring from the point, that is X upon X square. Okay, what is R? R is the radius of the ring. Radius of the ring is R, the power 3 by, that is my dE. Now you have to put here and you have to integrate this thing. Clear? Okay, so let us see. So our E net is equal to how much? That is integration of dE cos theta, correct? Integration of dE cos theta. Now what is cos theta? If someone asks you what is the cos theta, the cos theta will be from that triangle. Can you tell me what is cos theta? Yes sir, theta will be, cos theta will be x upon this distance. What is this distance? This distance is small r square into x square, correct? This will be x upon root over of r square plus x square, correct? So let us go to the next page and integrate this. So our E net will be integration of, what is the integration we have? K sigma 2 pi r dr divided by r square, then x square power 3 by 2 into cos theta. Cos theta is x upon r square plus x square to the power 1 by 1 by 2. Everything is correct? Yeah. So this way we will get integration. Now k like k to sigma 2 pi r. Now what is constant? See, x is constant. What is a variable here? We have a r as a variable. Okay. So it will become how much? X square plus r square to the power 3 by 2 and x square plus r square to the power. So it will become x square r square to the power 4 by 2, that is 2. Correct? Yeah, it is correct. So from here what you have to do? What you have to do? Oh, we have done one mistake here. Sorry. We have done one mistake. No. There is a one mistake we have done. I got it. Sorry, we have done one mistake here. What is the mistake we have done? See, we are considering a ring now. So if we are doing, there is no need of this thing. We are doing the integration for the this thing. Sorry. From my side. Okay, because our net field will be in this direction only, na, due to the ring. That is a fix. So the direction will be same only. So there is no need to take the component. Okay. There is no need to take the component. We can directly do the integration. See here how we can do the integration here. What is the approach we have to use? Basically, let me explain you in better way what you have to what I am trying to say. See, we are basically cutting our in one small ring, and due to the ring, we know that the net electric field is along the axis only. This field is along the axis, and if we are taking the component and doing again the integration, then we are integrating the ring electric field two times. So that means we are doing it two times. We are adding it two times. Okay, we are applying directly the ring electric field. Now the ring electric field is along the axis, that is fixed. So we have to integrate this thing. So this integration will give our net electric field. And what is the value of R? It is going from R equal to 0 from center to R equal to capital R. This thing you have to integrate. And if you integrate, you will what you will get? What is the value of K? That is 4 pi epsilon naught. Pi will be cancel out, 2 will be cancel out. So epsilon naught by sigma sorry. So this will become how much? Sigma and 4 pi by epsilon naught. So sigma by 2 epsilon naught into what is R into R is also 2 pi R, and x is there. X is the constant. I will take it out. Then we will get what? We will get R upon x square into R square into dr to the integration R equal to 0 to capital R. I told you how to do this integration. If you integrate this thing, you will get sigma upon 2 epsilon naught into 1 minus if you multiply this x upon root over of R square plus, correct? This is our net electric field. Okay, so this is our net electric field along the axis of the disk. The direction will be in this direction only, and the value is sigma upon 2 epsilon naught 1 minus x upon under root of R square plus x square. Okay, that is the electric field due to the disk. Now here we have a special case. Let's see that special case. If my R is tends to infinity, if R will become infinity, then disk is converted to infinite charge sheet, infinitely charged sheet. Okay, it will be converted to a infinite charge sheet. Means this sheet is going up to infinity, like plus infinity to minus infinity. Okay, the R is if R tends to infinity. So what is the electric field due to this infinite charge sheet? So if E net you will calculate, it will come out as a constant, that is sigma by 2 epsilon naught. If you put here what R tends to infinity, what is the value you will get? Sigma by 2 epsilon naught. So what is this thing? It means that if you are here also or here anywhere in that place, the electric field is always sigma by 2 epsilon naught by an infinite long charge wire which has a charge density sigma. The charge density is sigma here, coulomb per meter square. If it is given, then you can say electric field is sigma by 2 epsilon. For example, let us take one example. Suppose we have a one plate, okay, that is positive charge, infinite charge plate, that is positive charge. It has a charge density plus sigma, and we have another infinite positive charge plate which has a charge density minus sigma. Okay, you have to find E here, E electric field here, electric field here. What is the electric field in this condition? See, what is the approach to find? Due to this, the electric field will be in this direction. Due to this, the electric field will be in this direction. So they will be added up. So you will get sigma by 2 epsilon naught plus sigma by 2 epsilon naught. So you will get how much? Sigma by epsilon naught. This is the electric field which is you will also found in parallel plate capacitor. When we study in the capacitance, then you will find that the electric field energy is stored. Means the electric field is the energy which is stored between the two plates, and that is going to form a capacitor that we will see in the next chapter. If here you will calculate, you will get the E net is equal to 0, and here also you will get E net is equal to 0. Means we are able to store our electric field between the two metal plates. Means we can store the energy. The electric field consists of electrical energy that is stored between the two metal plates. So that is why it is very important, and this is the reason we have a capacitor and we have a capacitance. So we will discuss this thing separately in a capacitance, there where we will discuss about the parallel plate capacitance, that is in our syllabus. Clear? So that is our electric field due to the infinite charge sheet, that is sigma upon 2 epsilon naught 1 minus x upon under root of r square plus x square. Then we have seen the electric field due to the infinite charge sheet, that is sigma upon 2 epsilon naught, which is independent of the distance. Whatever the place you will give, the everywhere, means here also the electric field is sigma by 2 epsilon naught, here also the electric field is sigma by 2 epsilon naught, here anywhere here electric field is always fixed, that is sigma by 2 epsilon naught. And also we have seen this concept, the electric field is stored, the energy, it is a form of energy which is stored between the two metal plate, and the energy which is stored, it is sigma by epsilon naught. Clear? Till here anyone have a doubt? Please tell me. No doubt? Okay, shall we proceed further? Let us proceed further. No doubt? If anyone, please tell me. Okay. Okay, so let's move. Now our most important case. That is electric field due to the hollow hemisphere. Okay. Now we want to discuss the electric field due to the hollow hemisphere. Correct? Okay. Electric field due to the hollow hemisphere. So let us see what is the electric field due to the hollow hemisphere. This is a hollow hemisphere which has a radius r that is given. It has a I think it is not visible to you. So let me do something for you that me. I hope this is visible. Yeah. So this is a hollow hemisphere and the radius, suppose this is my center. Okay. This is my center. Okay. And suppose the radius is r. And it is a positive charge. I want to calculate the electric field at this point. Okay. I want to calculate the electric field at the center. Okay. That is my question. Now how to calculate it? How to calculate the electric field due to the hollow hemisphere? So what will be our element? See how to take the element. First of all, suppose this is my center. Okay, this is my center. So from angle theta, from horizontal, we will go to d theta, and we will rotate. See, I am trying to say this is my hemisphere. From angle theta, we will go to d theta, and then we will rotate like this to cover the whole hemisphere. Clear? So we will rotate like this. Correct? We will rotate like this. So it will form a one small. It will form a small ring. It will form a small ring which having a thickness. How much? What is the thickness? Thickness will be r d theta. Correct? And what is the radius? Radius is r or something else. See, this is my r. This will be r cos theta, and this will be r sin theta. So what is the radius? Radius will be r cos theta. Okay. Suppose I am going to distance. What is this distance? This distance will be r sin theta. Correct? So this thing we know. Now we have to calculate the electric field. So, and what is the charge on this? The charge is dq. And what is dq? dq is obviously sigma. Sigma is why? Why sigma? Because it is a surface only, coulomb meter square. So what is sigma? How to write sigma? Sigma is a charge on this small ring. What is a charge? Sigma into what is the area you will write? Area is 2 pi r, 2 pi r into thickness, like length into breadth. So what is length? That is 2 pi r. R is how much? R cos theta. And what is thickness? Thickness is r d theta. Correct? What is dE? A dq. dq is 2 pi r square cos theta d theta upon distance. kq into x. What is x? X is r sin theta, because it is ring, na? What is the formula for ring? That is what you have to apply, because it is forming a small element we are getting is the ring. So kq into x divided by x square plus r square. So r square cos square theta plus r square sin square theta to the power 3 by 2. Clear? This we have to integrate. What is the limit of theta? Theta will be from 0 to how much? 0 to pi. Think first. Don't say 0 to pi. If you rotate from 0 to pi, then you will cover this whole thing 2 times. So you have to rotate from 0 to pi by 2. Then you will cover in 1 time. So you have to integrate from 0 to pi by 2. So what is cancel out? See, sin square theta plus cos square theta is 1. R square will r cube. From here r cube will be cancel out. This you will get how much? K is 4 pi by epsilon. So we will get how much? K is 1 upon 4 pi epsilon naught. So it will become 1 upon 2. Like sigma is mess, na? Sigma is here. Sigma by 2 epsilon naught. Correct? And then you will get sin 2 theta, because r square and everything will be cancel out. Okay, r cube will be cancel out. Sin square theta into like it will become sin 2 theta. Sin 2 theta integration from 0 to pi by 2. This will become 0 to pi by 2 sin 2 theta. Integration is 1 by 2, so it will become sigma by 4 epsilon naught. That is minus j cap. So you can also see from a hollow hemisphere the electric field is constant, that is sigma by 4 epsilon naught. It does not depend what is the radius. It doesn't matter. Its radius, if suppose I ask you the question, a hollow hemisphere having a radius of r, the electric field is even. If I increase the radius 10 times, what is a new electric field? Again it will remain same, because it is independent of the size or radius of the hollow hemisphere. Clear? So these are some famous questions of NEET. In NEET, they will ask you the question like this only. They don't ask you to derive the formula. Okay. Why I am telling you the derivation? Because you should know how to, suppose, because in the for the J student, they can give you any geometry, na? Anything they can give you, and they will be derived from this geometry only. Okay. So for that you should know how to do the calculation of electric field. So these are the different cases. If you see, we just do the revision once. What are the different cases we have seen till now? What are the different cases we have seen till now? I will give you the conclusion also. I will write in one separate page. I will write all the formulas so that it will be easier for you. First, we have seen the infinite long wire. Here we have seen E parallel, E perpendicular. Clear? Then after that, E perpendicular we have seen, and this is the conclusion for us. Similarly, then we go for the semi-infinite case, infinite case. Then after that, we have seen ring for general case of ring, and we have also see the formula for ring also. That is the electric field we have seen for ring. I think we haven't seen for ring, or we have seen. Yeah, we have seen. This is the for ring formula. Then we have seen the general case. After that we went to the disk. This is the disk which we have seen. Then infinite sheet, and the last we have seen the hollow hemisphere. So these are all the 4 cases which you have to remember. Every formula should be remembered to you. Anyone can ask you anytime all the formula with how to apply this formula with the magnitude, direction, everything. Okay. So this is how we have completed the electric field calculations to calculate the electric field for the different geometry. In the next class, we are going to start with the new concepts, and we will solve some problems, and then we will move to the electrostatic potential energy. Clear? So till then, take care, bye, and please like it, subscribe it. Thank you.